All right, here are the notes for lesson 1.9, focusing on inverse functions. As always, I have the written notes posted, so I'm going to skip through some of the definitions and note-taking parts and just do examples. So first one here, we have f of x equals 4x, g of x equals x over 4, and we want to verify that they are inverses of one another. And if we want to do that, we need to do f of g of x. So we got to do the composite function and see what happens. F of g means that this is the f function for x, but it's going to be composed of, so we're going to replace this x with x over 4. We're replacing our x with g of x. So that becomes 4 times x over 4, which is the same thing as 4 over 1 times x over 4. Multiply top, multiply bottom, you get 4x over 4. The 4's cancel, and you're just left with x. And that's what we want to see when we're testing for these functions being inverses of one another. When you make them composite, you just end up with x. And in the first case, we do, but we also want to try g of f of x. So now we're going to do the g function composed of f, and the g function is x over 4, but we're going to replace x with our f of x function, which is 4x. And so when we actually do the composite function, it is 4x over 4, which again the 4's are going to cancel, and we're left with x, which is what we want to see, and that tells me that these two are inverses of one another, because the composite function here gives you x, and the other composite function going the other way also gives you x. Moving on to the next one, we're going to use these notes right here to actually do a graph of an inverse function, or a function and its inverse. And so really what I'm going to show you here is just that we have our x's and our y's of our original function, and that those have been flipped when you have the inverse. And so if we go to this problem here, I have f of x, I have my inverse f negative 1 of x, and when I plug in points to do an xy table for f of x, so I just plugged in negative 2, negative 1, 0 into my original function, and these are the inputs and outputs I got. Now, using that rule that I show you in that first screen, this here, I just have to flip my x's and y's. So all my y's over here become my x's, all my x's become my y's over here, and then I can graph and see what happens. And so I'm going to complete that graph. I'm going to pause, complete it, and then I'll show you what it looks like just to save some time here. All right, so after I have it graphed here, this blue line is just y equals x. It's this right here, y equals x. And why it's on there is to show you the pink line is my inverse function, the green line is my regular function, and what's happening is that these two functions, the inverse and the original, are actually reflections of one another over that line y equals x. And so it's just graphically showing you what happens with inverses. They always reflect over this diagonal line y equals x. Okay? Again, the more important thing to note is just how these things flip, x and y's flip, for inverse and original. Moving on, we have one-to-one functions. One-to-one functions are functions that pass both the vertical line test and the horizontal line test. And the horizontal line test pretty much just means if we can draw, it's similar to the vertical line test, if we can draw a line horizontally through a function and it only passes that or hits that function at one point, then it has an inverse. If you draw a line through a function and it hits it in 2 points, it will not have an inverse because it's not one-to-one then. So the example here is this pink line here. As it passes through horizontally, it only hits the graph at that 1 point, meaning that this function x cubed minus 1 is going to have an inverse, and it is one-to-one because it would also pass the vertical line test. B here, you can see the horizontal line test is failing because it hits the graph there and here, and so it's not going to have an inverse function. And so that's similar to what we did with the vertical line test in the horizontal, but the horizontal line test is similar to the vertical, but this is just talking about if it's going to have an inverse function or not. Okay, here's just the notes for finding an inverse. So we're just changing f of x into y. We're switching x and y, and we're going to solve for y, and we're going to do that here in one problem, and then we are going to be done with the notes, the video notes, to keep them nice and short today. So, following our list here, we want to change f of x into y first. So this is y equals y equals 5 minus 3x divided by 2. And then we want to switch our x's and our y's, and then we're going to solve for y. So what that means and what that looks like is this is going to become x equals 5 minus 3y over 2. And now I got to solve for y. Okay, so the first thing I need to do, multiply both sides by 2 so that these cancel out down here. Now I have 2x equals 5 minus 3y. I got to subtract 5 on both sides, so this is 2x minus 5 equals negative 3y. Divide both sides by negative 3. And I'm going to have my final answer here. This is going to be negative 2 over 3x plus 5 over 3 equals y. And then my last step is just to change y into f of negative 1. And so the final answer is f of negative 1 equals negative 2 over 3x plus 5 over 3. Okay. Now there is one more on here. If you would like to see that, just email me saying, I don't really get how to do the inverses, or can you show me the last problem? And I'll make an individualized video. Okay? I will post the new update. I haven't updated the homework yet. I will post the new updated homework problems shortly, if not already up.